work on the Leetcode problem n queens. So this video is coming after a long time, and for people who are following the news, you must have read about Amazon layoffs. So I was one of the people who was affected by it, but luckily I was able to find a new position within the company, so I'm good right now. So yeah, I'll be hopefully uploading it more often now, and yeah, keep subscribing if you want to see more videos like this. So anyhow, this problem, n queens problem, is this problem actually you won't be asked during your interview because this is kind of like a textbook problem for learning about backtracking, and it's a case where as soon I think any data structures book, when you come up to backtracking, this is the problem that will be given as an example. So this is widely available, the solution for it. So most likely you won't be asked, but you'll be asked some variation of it, such as solving a maze, which uses similar principles. So yeah, I'm not even going to go into a very detailed explanation because this is something which you can actually find on YouTube. So I'm going to attach a link to a very good explanation I found. But for people who are looking for only the solution, I have one for you. So in this problem, you'll be given an integer n, and this value n represents the size of a board. So for example, if it's a 4, the value is going to be a 4 into 4 board. So you need to place a queen on each row of the board, such that none of them are attacking each other. So people who are familiar with chess, they'll know that the queens can move horizontally, diagonally, and vertically. So you should just make sure that the queens are placed so far away from each other that they're not able to attack each other. So this is an example they've given of how we could do it. So one more unique thing is the result should be in the form of list of list. So it's a case where we don't want just the first result. We want to list out all available results, and we want to have it in a list format. So I've already created some methods which will help us. So this problem is actually a pretty long problem, so it'll be difficult to fit in a video. So I already typed some of the code we'll be using. The first thing I'll do is create a variable to store the results. So yeah, we're just using it to return the result. Another thing I'm going to do is, given this value input n, I want to convert it into a board of size n into n. So this is what I've done here. So given this integer n, we want to create a square board with a number of rows and columns equal to n. So this is basically a 2D array. So yeah, let me just create that. I'm sorry, I didn't see that. I'm having some difficulty with my laptop. So this thing essentially just initializes the board. Next thing I'm going to do is going to solve it, and the way to solve it is using backtracking and recursion. So I've created these two methods. One is a isValid method. This method is supposed to check if we are allowed to place a queen on any of the cells of the board, and this method is a recursive function we'll call in order to solve this problem. So the input will be passing to this method, solve n queens. So we'll pass the board we just created. So this value integer is used to represent the current row. So in the first, initialize it to 0. The size will be the actual max size of this, the input array that we are passing. And finally the result. So this is the one where we'll keep adding the values of the result, and we'll save it. So yeah, this is what we're going to do. So for solving n queens, so like all recursive functions, we need to come up with a base case and a recursive case. So I already said we have this variable current. We used to keep track of the current row which we are processing. So if the value exceeds n, then we know that we have already traversed all of the rows, and then we can just return the result. So we can say that if So we need to return the board, but we need to return it in a format of list of strings. So yeah, I didn't go through the problem in detail, but yeah, this is how they want the result to be. So it's going to be a list of strings where each of the values inside of this, the resultant list will be like where the queen should be placed on the board. So for that, I created another method which essentially takes a 2D array and converts it into a list of strings. So what I'll just say is that get list from 2D array. and I pass the board to it. So yeah, I keep adding the result to it because you have already finished processing it. Else, so now the recursive case. So the way we are going to do is we are going to start placing the queen at each cell and check if it's valid. So we say is valid, and the input for that will be the board and the current row and column, which is so we are just going to pass the current row and column. This is what it represents. If it's valid, we place a queen there. So we just call solve n queens recursively. So we just say solve n queens. We pass. Oh wait, first I need to set it. So board. So the current represents the current row. So we just say that, and I. So we just place a queen at that cell, and then we pass it recursively. So we just say board. We increment the value of current, size, and result. So everything else remains the same. After we are done processing it, we revert it back. So we just say board. Yeah, so essentially what we are doing is they want us to find all possible solutions. So even if a solution is found, we need to move to the next cell to see if a different solution is available. So this is what we are doing. We're going to call it recursively whenever it's valid. So in case we find a case where nothing is valid, we don't recursively call it. So yeah, this way we'll be able to find all possible solutions. Now for creating the method is valid. So in order to check if a cell is valid, we need to first determine when is it invalid. So we know that for it to be invalid, there must be either in the row above it or in the diagonal, leading diagonal or the reverse diagonal, there must be another queen placed on it. We don't need to do a row check because essentially we are going to we are solving it one row at a time. So yeah, so these are the 3 checks we need to do. We need to make sure that in the same column we don't have any other queen available. So for doing that, we'll just say for so you're going to do this for any of the values before the row. If so, we need to just check for that particular row and that column, there isn't a queen available. So this one does like a column check. After that is complete, we now need to check in the leading diagonal to see if there's a queen available. So the way we are going to do is we're going to create 2 new variables, int I equal to row minus 1 and column equal to I should say j equal to column minus 1. So for example, if we select this cell, we are going to initialize it to cell diagonally left of it, and then we are going to create a while loop. So while I I'm just going to write the condition for decrementing because I keep forgetting it. I minus. So what we're going to do is we're going to check if any of the values in the leading diagonal also has a queen. So we'll just say if board so yeah, this condition makes a check in the leading diagonal to see if a queen is already placed there. Else we check in the reverse diagonal. So for this one we'll say I is equal to row minus 1. But j should be equal to column plus 1, so since it's in the opposite direction. So here we'll just say j less than, oops, and we'll say j plus plus. So yeah, essentially this condition is checking the reverse diagonal. So after all of this, you're not able to find a queen anywhere, we just say return true. So yeah, let's do a recap of the solution. So for this problem, first thing we are going to do is we are going to recursively check each row. And the way we do it is we have a base case and a recursive case. The base case is if the current row is greater than the size n of the board, we just add the board into the result and return it. Else, we keep trying to place a queen in every cell of the row, check if it's valid. If it's valid, recursively move on to the next row, which is what we're doing. We're saying current plus 1, and we keep checking each row. And we keep doing it until we are able to find all possible solutions. And the way we check is we have 3 conditions to check: whether there's a queen already placed in the existing column, or it's in the leading diagonal or reverse diagonal. So yeah, let's try running the solution. Current greater than equal to, oh, I just renamed its size. So yeah, hopefully this one would work now. Let's try again. I guess we didn't initialize the row correctly. So we're supposed to put a dot. So I think I just left it empty, so which is wrong. So let me try it again. Okay, the reason you're seeing so many errors is I kept practicing it just before recording this video, and I think I used different variables names. So that's the reason I'm making a mistake now. So yeah, let's try submitting it. Alright, the solution was accepted. So yeah, leave comments and let me know if the solution could be any better. I'm also going to leave a link to the more detailed explanation which will help other people solve it.